This is a video on conservative vector fields. The question states, determine which vector field is conservative. We have the vector field f of x, y, z is equal to cosine of y, comma z minus x sine of y, comma y minus 2z. And g of x, y, z is equal to 4x squared minus 2yz, comma x minus y squared, comma xz. So recall that to find out if a vector field is conservative, we take the curl of that vector field and see if we get 0. And the curl of a vector field is equal to del cross that vector field, which is the determinant of the matrix I, j, k, del over del x, del over del y, del over del z, m, n, p, where m, n, and p are the I, jth, and kth components of the vector field. So we can substitute in our m, n, and p is cosine of y, z minus x sine of y, and y minus 2z. So now let's take the determinant. To find the ith component, we take del over del y times y minus 2z, and the partial derivative with respect to y of y minus 2z is 1. And then minus, and then we take del over del z of z minus x sine y, and that's also 1. So we get 1 minus 1 times I. For the jth component, we subtract, then we take del over del x of y minus 2z, and that's equal to 0. And then we take del over del z of cosine of y, and that's equal to 0. So we get 0 minus 0, j. And then for the kth component, we take del over del x of z minus x sine of y, and that's negative the sine of y. And then we take del over del y of the cosine of y. So we subtract negative the sine of y. And that's times k. So now we simplify. 1 minus 1 is 0. 0 minus 0 is 0. And negative the sine of y minus negative the sine of y is also 0. So this is indeed the 0 vector. So now let's find the curl of g. So for the curl of g, I substitute my m, n, and p with 4x squared minus 2yz, x minus y squared, and xz into this determinant. So now let's find the determinant. We take, for the I component, del over del y of xz is 0. Del over del z of x minus y squared is also 0. So I get 0 minus 0i. Then I subtract, and for the j component, del over del x of xz is z, and del over del z of 4x squared minus 2yz is negative 2y. So we get z minus negative 2y times j. And then for the kth component, I get del over del x of x minus y squared, and that's 1, and del over del y of 4x squared minus 2yz is negative 2z, so I get 1 minus negative 2zk. So the first component is 0, but notice the second and the third components are not 0. So what's important is that this is not the 0 vector. So the curl of f is equal to 0, and the curl of g is not equal to 0. So I can conclude that the vector field f is a conservative vector field, and the vector field g is not a conservative vector field. And I'm done with the problem.